Hello, good day, BSE 3 Math. So this is our fourth lesson for our subject BSE M32 number theory with the title of Proof Techniques, focusing on the first basic proof, which is direct proof. So let us first define some proof terminologies. First, proof, it is a valid argument that establishes the truth of a mathematical statement. So ang gagawin natin dito, we are going to prove different mathematical statements. And of course, we are going to use some theorems. So theorems, it is the statement that has been proven to be true. So hypothesis or premise, so it is an assumption, often unproven, defining the structures about which we are reasoning. Okay, so again, on our lesson number 4, we will be focusing on the first basic proof, which is direct proof. But, pakitandaan itong different proof methods na ating i-discuss later on. So, for proving implications P implies Q, we have direct proof, which is you are going to assume P is true, and then we will use that to prove Q. Next, indirect proof, which has two different types. First one is proof by contradiction. So we are going to assume uh, P and not Q, and show this leads to a contradiction. So, ayan, pag-aaralan natin siya, focus natin siya next lesson. Next one, proof by contrapositive, not Q implies not P. So, we are going to assume not Q and prove not P. Okay, or negation. Negation kasi yan. And then, lastly, proof by mathematical induction. So, unahin muna natin, no, C, direct proof. Okay, so we have three different definitions that we need to remember. First definition, or definition number 1, an integer number n is even if and only if there exists a number k such that n is equal to 2k. Next, definition number 2, an integer number n is odd if and only if there exists a number k such that n is equal to 2k plus 1. And then lastly, for consecutive numbers, two integers a and b are consecutive if and only if b is equal to a plus 1. So it is very important to remember this three definitions. Ayan. Because we are going to use it hanggang if I'm not mistaken, hanggang indirect proof. Ayan. So now let us move on to our first example to prove using the direct proof. Okay, so for our first theorem, for all integers n, if n is odd, then n square is also odd. Okay, so ang sabi po sa ating proof methods, no, we are going to assume P is true and prove Q. Okay, so if n is odd, so first we will assume that n is odd. Okay, so assume n is odd. And then after, since odd siya, then there exists an integer k such that n is equal to 2k plus 1. Based po doon sa ating definition earlier. Ayan. So, definition number 2 natin, n is equal to 2k plus 1 if it's odd. Now, let's move on no. Okay, so meron na tayong assumption and we already have our first definition. So, thus, n square, n square po, is equal to 2k plus 1 square. And then, perform lang natin siya, no? So, n square is equal to 2k plus 1, 2k plus 1 using the FOIL method. So, we will have 4k squared plus 4k plus 1. So, that is our n squared. And then, to prove that this one is odd, ayan. So, nilabas lang natin yung 2, no? We are going uh, to use this definition. And then, ayan, n square na siya, n square. Ayan, I forgot to put n square. Then, there exists, pwede tayong gumamit ng kahit anong letter. An integer, let's say for example, m, such that m is equal to 2k squared plus 2k. And then, with the solution that we had earlier, therefore, 2, 2k squared plus 2k plus 1 is equal to 2m plus 1. With m as our integer, so therefore, ibig sabihin or thus, n square is also odd. Tapos ang ating proof. Okay? So, ulitin natin siya, no, from the start kasi sinusulat ko, no, medyo putol-putol. Okay, so for our first example, if n is odd, then n square is odd using the definition number 2 that every integer n, then we have here n is equal to 2k plus 1. So, we have to assume that n is odd. Then, there exists an integer k such that n is equal to 2k plus 1. So, that it satisfies the assumption that n is odd. Then, we will prove that our q, this one, is also odd. So, gamitin natin yung ating definition number 2 so that n squared is equal to the quantity of 2k plus 1 squared. And then, perform lang natin siya. And then, we will have another integer. So, pwede kayong gumamit kahit anong letter. So, I used m here. And then, that is 2k squared plus 2k. Tapos, i-substitute mo lang siya. And kung makikita ninyo, it satisfies definition number 2. Okay? So, ibig sabihin, na-prove natin na kung si n ay odd, then kapag yung n ay in-square mo, odd pa rin siya. Okay po? So, another example naman po, and I think this is the last example. Ayan. So, for example number 2, theorem natin, the sum of any two consecutive numbers is odd. So, balik tayo doon sa ating definitions, no? So, we will use two different definitions here. So, definition number 2 and definition number 3. Dahil meron tayong consecutive numbers and odd numbers. So, tatandaan natin, no? Kapag kay odd, 2k plus 1, and then kapag kay consecutive, b is equal to a plus 1. Okay? So, let us prove example number 2. Okay, so for our second example, ayan, 'di ba? So, we will assume that a and b are consecutive numbers. Okay, so assume that kasi ano two consecutive numbers siya. So, ibig sabihin, gamit tayo ng A and B as consecutive numbers. Assume that A and B are consecutive numbers. Consecutive numbers. And then, ano daw yung ating cue dito? Yung sum daw. Then, the sum of A plus B is odd. Ayan. So, assumption natin dito, first assumption natin, ito, A and B are consecutive. Based doon sa ating third definition, so, A and B are consecutive numbers. We know that B is equal to A plus 1. Tama, 'di ba? Yung sabi kanina, ang B natin ay A plus 1. So with this definition, thus the sum of A plus B is equal to, that would be A plus A plus 1. Nakuha po? Kinuha ko si A. Tapos si B, kinuha natin siya dito base doon sa definition number 3 natin. Thus, we will get the sum of 2A plus 1. So, with the integer, ayan, pwede tayong gumamit ng ganito kung gusto niyo pa naman, pero pwede din naman na diretso na. So, then, there exists an integer k such that A is equal to k. Therefore, A plus B is equal to 2k plus 1. So, the sum of A plus B is odd. Tapos, ang ating proof. Ayan. So, base po doon sa ating definition number 3, again, balikan natin yung definition number 3 natin. Two integers A and B are consecutive if and only if B is equal to A plus 1. So, ginamit natin yung definition number 3 here. Ayan. Tapos, since sum siya, pinag-add natin si A plus B. Using the definition number 3, sinubstitute natin yung value ni B, which is A plus 1. Then, we have here 2A plus 1. So, then, there exists an integer k such that A is equal to k. Therefore, A plus B is equal to 2k plus 1, which fits definition number 2. 'Di ba? So, the sum of A plus B is odd. So, balik tayo kay definition number 2. We have here 2k plus 1. So, I hope that one is clear, no? Ganun lang po kadali si direct proof. We will make an assumption that P is true, yung una nating statement is true, so that gagamitin natin siya to prove letter Q. Okay po? Sige, let me think of another example. Using even numbers naman yung definition number 1 naman natin, no? Sige. Okay. Uh, i-keep ko na lang yung ano, no? Okay, so let me think of an example. Okay, so direct proof. Para pag-upload ko nito, no, makita ninyo siya. Hindi ko napansin na hindi pala ako nakapagbigay ng sa even. Okay, so theorem natin, if n is an even number or even integer, then 7n plus 4 is an even integer. Okay. Sige, pwede. Ayan. So, example number 3. Oh, I forgot to put example number 3. Para ano tayo, no? Pag-upload ko. Okay, so we have here example number 3. So, even integer siya. So, we will use definition number 1 that we used earlier. Ayan, definition number 1, an integer number n is even if and only if there exists a number k such that n is equal to 2k. Ayan. Okay, so for example number 3, so ang ating P statement dito is n is an even integer. So assume, ayan, palitan ko, wag red. Ayan. Assume that n is an even integer. Then there exists an integer k such that n is equal to 2k. So, base iyan sa ating definition number 1. Okay, so now 7 n plus 4 ay ipoprove natin to be even. Lagay ko dito si 2k. So, palitan lang natin yung n ng 2k. So, that would be 2k plus 4 equals 2k. So, this will be 14k plus 4 equals 2k. So, pwede nating ilabas si 2. That will be 7k plus 2 equals 2k. Then, there exists an integer. Gawin natin ulit m such that m is equal to 7k plus 2. Therefore, 7k plus 2 is equal to 2m. Thus, 7n plus 4 is an even integer. Ayan. So, tapos yung ating proof. Again, I will explain it. If n is an even integer, then 7n plus 4 is an even integer. So, kunin natin this one as our P. We will assume that it is true. So, assume that n is an even integer, then there exists an integer k such that n is equal to 2k. So, base ito sa definition number 1. So, 7n plus 4 is equal to 2k. And then, palitan lang natin si n ng 2k. So, that is 7 multiplied to 2k plus 4. And then, that is 14k plus 4. Tapos, then there exists an integer m such that m is equal to 7k plus 2, which is here. Therefore, 7k plus 2 is equal to 2m. Thus, 7n plus 4 is an even integer. Okay po, so ayun lamang for our first lesson or lesson number 4, which talks about direct proof. Again, remember the three definitions here. Ayan, definition number 1, an integer number is n is even if and only if there exists a number k such that n is equal to 2k. Definition number 2, an integer number n is odd if and only if there exists a number k such that n is equal to 2k plus 1. And definition number 3, two integers a and b are consecutive if and only if b is equal to a plus 1. So I hope that you understand our fourth lesson in BSEM 32, and happy watching and happy learning, because I'll be uploading another video lecture for indirect proof that will discuss proof by contradiction and proof by contrapositive. So thank you very much for listening. God bless everyone and always keep safe.